Hi everyone, today we are going to discuss the properties of determinants and thereafter we will be solving some important questions of NCERT text. First, we are going to discuss one important property. Okay, the statement of the property, we are going to form the statement. But before that, let me give you the example. Let delta is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. Say one determinant is this. Now what I'm going to do is, we are going to express the elements of the first row as a sum of two numbers. Say A1 plus lambda 1, B1 plus lambda 2 and C1 plus lambda 3. Okay, A1 plus lambda 1, B1 plus lambda 2, C1 plus lambda 3. Now, we are going to verify that this determinant can be written as a sum of two determinants. So, how to write this? We can write this one, okay, as a sum of two determinants. A1, B1, C1, A2, B2, C2, A3, B3, C3 plus lambda 1, lambda 2, lambda 3, A2, B2, C2, A3, B3, C3. So you can form the statement like that in a determinant, if all the elements or some of the elements are expressed as a sum of two or more numbers, then the determinant is expressible as a sum of two or more numbers. Or one column is expressed as a sum of two or more numbers, that means all the elements are expressed as a sum of two numbers or some of the elements are expressed as a sum of two numbers, then the determinant is expressible as a sum of two determinant. Okay, now we are going to verify this property. Okay, to verify this property, we can simply expand this determinant. We'll expand this determinant along the first row. Okay, how to expand? We can expand A1 plus lambda 1. Then we can multiply. We know how to multiply this. We can multiply B2 C3 minus C2 B3. Then the second element, therefore it's a minus sign. So it will be B1 plus lambda 2. Then since it is the second element, you need to multiply A2 C3 minus A3 C2. A3 C2. Okay, the third element. What is the third element? Third element is C1 plus lambda 3. So C1 plus lambda 3. C1 plus lambda 3. Okay, this can be written as A2 B3 minus A3 B2. Right? We have just expressed as, okay, the product of these two numbers, product of these two numbers and product of these two numbers. This is a simple expansion along the first row of a determinant, what we have learned in our previous video. Okay, now what I'm going to do is how to simplify this. The very simple way to simplify this is, first we'll combine all the numbers, that is multiplied by A1, multiplied by B1 and multiplied by C1. That means we'll combine all the terms, okay, consisting A1, B1 and C1. So first A1, then B2 C3, then minus C2 B3. Okay, then, okay, leave this element now, lambda 1 into this, we will write afterwards, then minus B1 minus B1, A2 C3 minus A3 C2, then the last element is C1 plus C1, A2 B3 and minus A3 B2. Okay, now what is left out? All the elements, okay, consisting of lambda 1, lambda 2, lambda 3 are left out. So I'll just continue this plus lambda 1, okay, B2 C3, C2 B3, okay, then minus lambda 2, then A2 C3, minus A3 C2, okay, the last number, lambda 3 is multiplied with A2 B3 minus A3 B2, right? Okay, yes. We'll put a second bracket on these three terms, then we'll put a second bracket on the three terms. Okay, now let us convert this one to determinant. So first we'll convert this one, the first, second, third term will convert to a determinant. How can you convert to a determinant? So this will be simple determinant, okay, in terms of A1, B1, C1. This will be the first row, A1, B1, C1. Thereafter it will be A2, B2, C2, A3, B3, C3. Okay, because you can check once, like if you take A1, then you need to multiply B2, C3 minus B3, C2. Then it's minus B1, obviously it will be A2, C3 minus A3, C2. And similarly, you can explain the third term. And similarly, we can explain the remaining terms involving lambda 1, lambda 2 and lambda 3. So you can just write lambda 1, lambda 2, lambda 3 and remaining terms will be this remaining terms. Okay, in place of A1, B1, C1, here it will be lambda 1, lambda 2, lambda 3. There won't be any changes in the second row and the third row. So second row and third row will be A2, B2, C2 and A3, B3 and C3. So we have seen one thing, that if the terms of a row or columns are expressed as a sum of two numbers, then the determinant is expressible as a sum of two determinants. Okay? Now, we can move to the next property. What is the next property? Let us take one determinant. Okay? We'll take the determinant as let delta is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay? Now, we are going to write another determinant, okay? And delta 1. Okay? Delta 1 will write in this way, A1 plus lambda B1, A2 plus lambda B2, A3 plus lambda B3. Then there is no changes in the second column and second and the third column, C1, C2, C3. Okay? So how do you get this? We are using one operation. What is that? C1. So which row, which column we have changed? We have changed the column 1. So how do you get this? C1 plus. That means you change this, you have taken the same column and you are using this column number 2 by multiplying a constant, that is lambda. That means you are multiplying the second column by lambda and you are adding with column 1. So that we can write as C1 implies C1 plus lambda C2. Okay? Yes. This is our original determinant, and this is the determinant obtained using this property, that is C1 plus lambda C2. Now, what is this property? And this property says that there won't be any difference between these two determinants. Okay? That means the value of this determinant delta and value of this determinant delta 1 will be exactly same. Okay? Then how to prove or how to verify this? We are going to verify this now. Okay? Now how to verify? First, to verify this, we'll take this one. We'll start with lambda 1. How to prove that this lambda 1 actually nothing but this lambda 1 is lambda? How can you prove this? So we'll just go back. Okay? We can, to prove this one, we can use the previous property. What was the previous property? If a column is expressed as a sum of two numbers, then the determinant is expressible as a sum of two determinants. So obviously this can be written as a sum of two determinants. We are going to write as A1, A2, A3 and B2, A1, okay, this should be B1, this should be B1, okay, right? A1, B1, C1, A1, B1, C1, then A2, B2, C2, this will be A3, B3, C3, okay? That means you take all the elements A1, A2, A3, then you take all the elements B1, B2, B3, there is no changes in the column to column 3, then what will be the first column of the second determinant? Obviously the first column of the second determinant will be lambda B1, lambda B1, lambda B2, lambda B3. Okay, then what will be the second column? This is the first column, that means all the second elements you can consider as the first element of the second determinant, and there won't be any changes in the column number 2 and column number 3. So it will be B1, B2, B3 and C1, C2, C3. Right? Yes. To write this two determinants, we have taken the property that we have just discussed, that if a column is expressed as a sum of two numbers, that the determinant is expressible as a sum of two determinant. Okay, now what is our objectives? We want to prove that actually the sum of these two determinants is nothing but is exactly same as delta. How can you prove this? Okay, so this one will write as it is. Okay, A1, B1, C1, A2, B2, C2, A3, B3, C3, right? Now let us see what is the value of this determinant. Okay, now observe column 1 and column 2. Okay, what's the relation between lambda B1, B1, lambda B2, B2, lambda B3, B3? That means each and every element, that means corresponding element of column 1, okay, are proportional with the corresponding element of column 2. So we have already discussed in the previous lecture that if the corresponding element of one column is proportional with the corresponding element of the other column, then the value of the determinant will obviously be 0. So therefore this value of the determinant is 0. So this is equal to 0. Hence this is equal to lambda. So finally what we have verified? We have verified that lambda is equal to lambda 1. So this is the last property that we have discussed today. Okay, so we have discussed two important properties of determinant. Okay, using all these properties, now we are going to solve some very interesting and important questions. Okay, remember one thing, students, that while solving the questions, okay, I always will follow certain important steps, okay, which could help you to solve determinant in easier steps. Okay, let us take one very important example of NCERT. Okay, what is the question? The question is, okay, important questions. If x not equal to y, not equal to z, that means x, y, z all are not same, all are different, distinct elements, and lambda is equal to, okay, x, y, z and x squared, y squared, z squared and 1 plus x cube, 1 plus y cube, 1 plus z cube. Okay, if lambda is equal to x squared 1 plus x cube, y squared 1 plus y cube, z squared 1 plus z cube is equal to 0. Okay, then what we need to prove? Okay, here we need to prove that 1 plus, okay, to prove 1 plus x, y, z is equal to 0. This is our objectives. We need to prove that 1 plus x, y, z is equal to 0. This is a very important question. Okay, how to solve this question? Okay, to solve this, we'll start with the help of the determinant. Okay. We'll be using a property just now we have discussed. Have you seen the third column? So we'll start with delta. Okay, let is equal to x, y, z, then x square, y square, z square, 1 plus x cube, 1 plus y cube, 1 plus z cube. Right? Okay. Now, okay, this is equal to 0, so that we'll be using afterwards. Okay, now we'll be using a property. What is the property? That if a determinant, a column is expressed as a sum of two numbers, so obviously it can be expressed as a sum of two determinants. So we can write this one as like this. Okay, so x, y, z, x, y, z, so there will be x squared, y squared, z squared, and all the first element will be in the first determinant. Okay. So this is determinant 1, then there will be another determinant, okay, there will be another determinant, plus, okay, plus, there will be another determinant. What will be the determinant? X, y, z, x, y, z, then x squared, y squared, z squared, then it will be x cube, okay, x cube, y cube, and z cube. Yes. So we have expressed the determinant as a sum of two determinants. There will not be any changes in the first and the second column. All the first element will be 1, 1, 1 in the first determinant. The second determinant will be x cube, y cube, z cube. Okay, how to explore this? Next. So please observe the steps carefully. Okay. First determinant we'll write as it is. Okay. So, okay. First determinant we'll write as it is. X, y, z, then x squared, y squared, z squared, then it's 1, 1, 1. Okay, this is determinant 1. Now plus second determinant. Okay, second determinant, what you can do is from the second determinant, from the first row we can take x common, so the second row we can take y common, from the third row we can take z common. If you take x common from the first row, it will be 1 x squared, then it will be y, this will be obviously 1 if you take y common from the second row. Okay, so we have discussed in the previous class that if our element is common in a particular row, that can be taken out. So we can take x common from the first row, y from the second row. So if you take y common, so it will be 1 y squared, then if you take z common, it will be 1 z squared. So this will be multiplied by, this will be multiplied by x, y, z. Why x, y, z? Because I have taken x common from the first row, y common from the second row, and z common from the third row. Now let's compare this. Okay. Now this determinant and this determinant seems to be similar, but still some changes to be made. Okay. Okay. So with the help of some changes, I'm going to bring this determinant in the form of this. For that, what you need to do is, here the position of 1, 1 is the first column. So what we are going to do is, we'll shift 1, 1, 1 in the first column. So then we'll shift x, y, z in the second positions. But here x, y, z occupy the second column positions. So what I'm going to do is, here we'll be interchanging, okay, two pair of columns. Okay, if we interchange, we have explained you that if you interchange one pair of column, the determinant gets multiplied by 1 minus sign. Now in this case, to convert this one to this form, okay, we need to make how many changes? We need to make two changes. What is that? X 1, 1, 1 will bring to the first positions, then x, y, z will move to the third position. After that also we are not going to get this, because if x, y, z occupy the third position, here third position is x square, y square, z square. So here x, y, z will come to the third column positions, but x square, y square, z square will be the second column position. So again we will shift, interchange the third and the second column. So we will make two changes. Now for one change, for if we interchange one pair of column or row changes, that will be multiplied by minus sign. If we interchange two pair of columns of the rows, then it will be multiplied by minus 1 square. That means if the number of pairs interchanges, okay, is even, that I have explained in the previous video, so it will be plus sign. So therefore, there will not be any changes in the determinant. Okay, so what are you going to get? So we'll make two changes. After making two changes, what are we going to get? Okay, we are going to get after this is this. Look, this will be 1, 1, 1. Then it will be x, y, z. This will be x squared, y squared, z squared. Okay, now we are not going to change anything here. This will be, okay, 1, 1, 1. This will be x, y, z. This will be x squared, y squared, z squared, and multiplied by x, y, z. So why actually, maybe now it's clear to you that why this one to be changed in the form of this. So the big benefit, we are going to get it now. Have you seen that both the determinants are same? Okay, so we are going to take this determinant common. Okay, if we take this determinant common, what are you going to get? Okay, we are going to get this number. Okay, we'll take one determinant common. So it will be 1, 1, 1, x, y, z. So x squared, y squared, z squared, we have taken common. So if we take common from this determinant, 1 is left out, and plus only x, y, z is left out. So have you seen? This whole thing gets simplified to this expressions. We are not to worry about this, we need to only worry about one determinant. Okay? So what we are going to use, we are going to simplify this determinant. Remember one thing, one trick we are going to follow now. Okay? What is the trick? That in a determinant, if a column or a row consisting of all 1, so simple trick that out of the 3 1, you always try to make 2 1 0. That is a simple formula we are going to apply. So what I am going to do is, we are going to make this 1 0 and this 1 also 0. How can you do that? What operation you are going to use? So this element you want to make 0, you cannot make one element 0, then you cannot affect only one element. We are going to affect the second row. So how to do that? So R2, we are going to, okay, R2 will subtract from R1. So R2 minus R1. Why are we doing that? Simple. Logic is simple. Then you want to make 1 is 0. Okay? Yes. Now concentrate only this number. Okay? Now in one row you can operate two operations. So we need to make this one also 0. So we'll be using operations for the third row as well. So this will be R3. Okay? Why R3? Because we are going to change R3. R3 minus, okay, R1. Remember one thing. See, R1 we are not affecting. That means we are not going to change R1. Therefore, to subtract, always take help of R1. The row which is not affected, please utilize that row. Okay. Now, after doing that, what are you going to get? Okay. Since, have you seen in the operation here R2 is there, here R3 is there. That means R1 is not going to change. So it's 1x squared. So if you subtract y minus 1, it's 0. Then y minus x. Then here y squared minus x squared. Y squared minus x squared. Okay. Now we are subtracting 1 minus 1 is 0. Then z minus x. Then you are changing z squared minus x squared. Z squared minus x squared. Right? Okay. Then there is no change on this number. Done? Okay? Yes. You have seen that one column got simplified now. Okay? Now what will be the next steps? What is the next steps we are going to follow? Next steps we are going to follow is this. Okay? Yes. Have you seen this? The second row. Observe second row. What is the common factor in second row? Y minus x is there. Y minus x. What is the factorization of y squared minus x squared? Y plus x, y minus x. That means y minus x is common here in the second row. So when a factor, a number is common in a row, so you can take out. So obviously we will take y minus x common from the second row. Now similarly, z minus x is common in the third row. So y minus x and z minus x are the common terms which can be taken out. Okay? So we'll take out those two terms. What are the two terms we are going to take? We are going to take y minus x and z minus x, both common. Okay? If we take common, what will be left out? 1, 0, 0. Then this will be x. We have taken 1 minus x, 1 minus x. What y minus x you have taken common? So it will be 1. You have taken z minus x common, it's 1. So it will be x squared Remember this? We have taken y minus x common. So it will be y plus x will be left out. And here z minus x is not taken common. So z plus x will be left out. Done? Yes. Okay. Next. What is the next steps? Okay. Remember, don't forget to write these terms. Okay. These terms always will need to keep writing. X, y, z. Okay. Now, y minus x, z minus x. Okay, now we are going to expand this. Okay, how to expand this? Already I explained that you try to expand along that column where more number of zeros are there. Okay, so here 2 zeros are there, we will expand along the first column. We need to expand along only 1. If we expand along 1, so I am going to get 1 into z plus x. So it will be z plus x, now minus 1 into y plus x, that is minus y minus x, multiplied by 1 plus x, y, z. Right? Okay. Now, y minus x and z minus x. And this will, what will get cancelled out? X's get cancelled out. So it will be z minus y. Okay? This is 1 plus x, y, z. Right? Okay. Now what was given in the question? The question was given as like x, y, z. All are distinct, all are different. Since x, y, z, since x not equal to y, not equal to z, not equal to z, therefore y minus x, z minus x and z minus y cannot be equal to 0. Okay? But in the question, what was given? This expression is delta, and what was given in the question? It is given that this delta is equal to 0. That means it was given that this is equal to 0. So obviously this will be also equal to 0. Okay? Now, if this expression is product of these terms 1, 2, 3, this is equal to 0. Since product of this 1, 2, 3, 4, all the terms is equal to 0, but according to the questions, this 1, 2, 3, this terms cannot be equal to 0. So what is left out? It's left out only 1 plus x plus y, 1 plus x, y, z is equal to 0. Therefore, the outcome is 1 plus x, y, z is equal to 0. This is the proof of this particular question. Why I am telling this question is important? You have seen that maximum of the properties in this question you have used, and if you try 1-2 times, okay, this question will be very simple for you, and you know that question is really very interesting question. Okay, now move ahead. We are going to start other questions. Okay. There is one important question. Okay. This is also given in example. Okay. Prove that 1 plus a. Okay. 1 plus b 1 plus c. Okay. 1 plus a 1 plus b 1 plus c. Okay, this is equal to a b c 1 plus 1 by a plus 1 by b plus 1 by c. That you need to prove. This is also another very important question. Prove that 1 plus a 1 plus b 1 plus c is equal to a b c into 1 plus 1 by a plus 1 by b plus 1 by c. Okay. Now how to prove this? Okay, you can prove this one. I can write this expression down. Okay, that when we have to prove this, we have to prove this one as ABC 1 by a 1 plus 1 by a plus 1 by b plus 1 by c. That we need to prove. Okay. Now prove. Okay. So we write the determinant. What is the determinant? Determinant is this. Okay. Let delta is equal to, okay, 1 plus a 1. Okay. Then 1 plus b 1 then 1, 1, 1 plus C. Done. This is the question. Now, to start the questions, okay, what property you are going to use it, okay. So this you can get a hint from the steps given to prove, okay. To prove, it's given that A, B, C, okay, 1 plus 1 by A plus 1 by B plus 1 by C. So you need to concentrate these terms, either this or this. That means in these questions, you need to bring a term in the form of 1 plus 1 by A plus 1 by B plus 1 by C. I think this step should give you a hint how to start the questions. So you need the terms consisting of 1 by A, 1 by B, 1 by C. So what I am going to do is, I'll be taking A common from the first column. Okay, what I am going to do is, I'll take A common from the first column. Now, remember one thing, like you may be surprised, like, okay, A is not there in the first column, so how can you take common? Okay, that's what I say, that you need to prove in the form of 1 plus 1 by A. So you need to create a term in the form of 1 by A. So that's what we have taken A common. So if we take A common, what will be left out? It will be 1 by A, and this A is there, so you have taken A common, so it's obviously 1. So from here you have taken A common, so it will be 1 by A. Because this A is not there, obviously it will be 1 by A, and here also it's 1 by A. Now, similarly, from the second column you should take B common, from the third column you should take C common. So outside it will be A, B and C, okay? A, B, C, okay? So this term will be 1 by B, and this term will be 1 by B plus 1, this term will be 1 by B, okay? And this term should be 1 by C, this term also should be 1 by C, and this term should be 1 by C plus 1. Yes. Okay. So what I am going to do is now, okay, what is the next steps? What next steps we are going to follow? Please observe the terms very carefully. Okay. Now, in case if you add, like, okay, say, we are trying, we are exploring the steps, how to go ahead. Now, it may come to our mind on different steps, okay, and let us try row wise. If we add the rows, what are we going to get? So if you add R1, R1 plus R2 plus R3, so we are going to get 1 plus 3 into 1 by A. Here we are going to get 1 plus 3 into 1 by B. Here we are going to get 1 plus 3 into 1 by C. Have you seen that all the terms are different? Okay, therefore the of adding the terms in row wise. Let us try in column wise. So in column 1, if you add column 1 plus column 2 plus column 3. Okay? Yes. If we add column 1, we have to change column 1. How to do that? So you will change column 1 plus column 2 plus column 3. So how can you do that? So we have discussed the property today, the last property. That if a column is changed in the form of C1, C1 plus C2 plus C3, then there won't be any changes in the determinant. Okay? So hence, A, B, C. So what I am going to do is, we are going to use this property. That is column 1. We are going to change column 1. So we'll add column 1 plus column 2, column 3. So what will be the first element? First element will be 1 plus 1 by A plus 1 by B plus 1 by C. Will you follow this? This will be the first element because you are adding this element in these positions. C1 means column 1 will only change. There will not be any changes in column 2, column 3 positions. Column 1, how we are changing? Column 1 is column 1 plus column 2, column 3. Okay, this is the first element. The second element is 1 plus 1 by A plus 1 by B plus 1 by C. And similarly, what will be the third element? So third element will also be, what will be the third element? Third element, look here, 1 by A plus 1 by B plus 1 by C plus 1. Same, exactly same. 1 by A plus 1 by B plus 1 by C. Okay? Yes. Now, you are not changing anything in the column 2 position and column 3 positions. Okay? Column 2 positions, you have not changed anything. So what was the column 3 positions? Here, okay, here 1 by 1, here it was B, so here it was 1, you have taken common, so it will be 1 by B, these positions, and it will be 1 by B plus 1, and this will be 1 by B. Okay, here it was 1 by C, and it is 1 by C, and this is 1 by C plus 1. Yes, these are the elements left out. Okay, now, have you seen like column 1 positions? Okay, all the elements are common, so you can take out, because this 1 plus 1 by A, 1 by B, plus 1 by c, element is common. In the column 1 positions you can take out. So if you take out, it will be ABC, then 1 plus 1 by A plus 1 by B plus 1 by C. Done? Okay. Then what is left out? It's left out is 1, 1, 1, then 1 by B plus 1, 1 by B, then 1 by C, 1 by C, 1 by C plus 1. Okay, this is left out. Now, 1, 2 more steps are left out. The moment you come to a step like that, that means if you get a column or a row consisting of all ones, that means your steps will be very, very simple. I mean, that will be a simple trick we are going to follow that I discussed in the previous question. What I am going to do is, we are going to make any two ones of this particular column 0. Okay, so we'll go ahead with steps. Okay, what will be the next steps? The next steps will be like that. Okay, so what? First of all, you need to confirm the operation you are going to do. What operation we are going to do is this one. So we are going to change R2. So R2, we are going to change R2 minus R1. So that means if you subtract this one minus this, then only it will be 0. So R2 minus R1. Then similarly, we are going to change R3 also. R3 minus R1. Okay. So if you A, B, C, okay, A, B, C, and will be A, B, C, okay, then 1 plus 1 by A plus 1 by B plus 1 by C, okay. Now this will be 1 by B, 1 by C, and this is obviously will be 0. Then 1 by B plus 1 minus 1 by B, so it's 1 will be left out. 1 by C minus 1 by C, it's 0. Then 1 minus 1, it is 0. Then 1 by B minus 1 by B, it's 0. Then 1 by C plus 1 minus C. This R3 also you are subtracting from this. 1 minus 1 is 0. 1 by B minus 1 by B is 0. 1 by C plus 1 minus 1 by C is equal to 1. I repeat the steps once. Okay? Yes. What you have done, R2, you have changed this. Okay? R2 minus, this one is R2. So it will be R2 minus R1. Okay? R3 minus R1. Okay? So R2 minus R1. That is 1 minus 1 is 0. 1 by B plus 1 minus 1 by B, it should be 1, right? Then 1 by C minus 1 by C is 0. Next for R3, this is R3. R3 also we are going to change with the help of R1. 1 minus 1, 0. 1 by B minus 1 by B, 0. 1 by C plus 1 minus 1 by C is 1. It's done. Okay. Now, after doing that, we are going to expand. Remember one thing. Some of the questions are given to use the properties of determinants. Please do not try to expand the determinant without using the properties. So there will be two problems in that case. The problem is the steps will be bigger, okay, and you will not be able to answer that question according to the expected steps. Okay, that means when a questions are given in the form, you need to always use property. Okay, now what is this? A, B, C, then 1 plus 1 by A plus 1 by B plus 1 by C. Done? We are going to expand. We are going to expand along the first column. If you expand along the first column, only along 1 you need to multiply 1 into 1. So it will be obviously 1. So finally you got the answer. So that is equal to A, B, C, 1 plus 1 by A, 1 by B plus 1 by C. So this is another very important questions. Okay, so we'll be solving more 1-2 questions, and then the remaining questions we'll be solving in the next class. Okay, so what is the next question? We'll be taking 1-2 questions from the exercise. Okay, exercise questions. We'll just continue exercise questions. Okay. That, so we'll be solving like questions on numbers. Okay, we'll be solving a question on number 235. Okay, 235, 789. Okay, 789, 65. Okay, 7, 75, okay, 65, 75 and 86 is equal to 0. So I have to prove this. That 2, 3, 5, 7, 8, 9, 65, 75, 86 is equal to 0. So how can you prove this? Remember this, that we are going to prove this one with the help of the properties. So how to prove this? Okay. Let delta is equal to 2, 3, 5, 7, 8, 9, then 65, 75, 86. Okay. What steps we are going to use it? Okay. A simple steps we are going to follow is this. Okay. Our concern should be on this number 65, 75, 86. Now, is there any direct relation between 7 and 65? Okay, and we try to see is there any relations if these two columns are proportional. Had it been proportional, then we could have written this one is directly 0, but they are not directly proportional. So what I'm going to do is we are going to write in this one. We need to worry about the first column 7, 8, 9. So what we're going to do, we're going to simplify the 65. 65 you can write as 63 plus 2. Okay, and this is a 73. Not 73. We are going to write 72. So I'll just tell you why you need to write 72, not 73. And this is 81 plus 5. Okay, simple trick I'm following is that 63 is a multiple of 7 and 7 into 9, 63. That means 63, 72 and 81. All are multiples of 7 into 9, 63, 8 into 9, 72 and 9 into 9, 81. So we are going to write this one as a constant multiple of either this column or this one. Okay. Now, what will be the next steps? Now, next steps will be very simple. What is that? So we'll be using our property that we have discussed today. What is that property? The first property we have discussed. That if a column is expressed as a sum of two numbers, therefore this determinant is expressible as a sum of two determinants. What is that? So 2, 3, 5, 7, 8, 9, then 63, 72, 81. Okay, and plus, okay, 2, 3, 5, then 7, 8, 9, okay, 2, 3, 5. I think it should be simple for you right now. Okay, the third column we are expressing as a sum of two numbers, then we are expressing as a sum of two determinants. So now what is the great advantage of this determinant now? So compare the second column and the third column. Okay, 7 into 9, 63, 8 into 9, 72, 9 into 9, 81. That means all the corresponding elements of the second column are proportional. And what is the advantage of this? Have you seen? That is, first column and the third columns are identical. So we are going to use two different properties there. That means if two columns are, the terms of a two column, corresponding terms of a two columns are proportional, then the value of the determinant is 0. And if the two columns are identical, then also value of the determinant is equal to 0. Therefore, is equal to 0. Have you seen that? We have expressed this one, we have proved this one, only simple properties. Okay? Yes. So there are more interesting questions in the exercise, okay, that I'm going to solve in the next video. Okay, so with the help of this, you try as many questions as possible for you. Okay, thank you for watching this video.